So wrapping up our discussion of the Alt-LS here in the third segment, we've been through the entire WriteStats and all its side issues of user identification and time and so forth. And we're finally back to list. We digress to WriteStats on line 70 and said we get to the directory traversing a little later on, and it is now later on. So we have a test here that uses a macro similar to isReg to test to see if the file in question is a directory. And if it is, we're going to traverse the directory and list all of the files in it. And we'll also deal with the possibility that we need to do so recursively. Subdirectories like sample being listed in recursive calls of list. First, though, let's look at how we even access the content of a directory. Now, as we will discuss in an upcoming kind of final lecture where we'll draw a lot of the underlying systems details here, a directory really is a file of data like any other file of data in a certain sense. It's not normally listed or edited, but it does contain within it information about file names and where those files are on the disk. The details to come in a later segment. But for now, the system call that is used to access the directory, and I'm speaking a little too quickly there, I'm not sure it really even counts as a system call because the directory is just open text or open data. The call to do so is opendir. And you give it the name of the directory, and it returns a pointer to a capital dir, which is a built-in type, and it represents an open directory. It's a little bit like the analog of capital FILE, representing an open file. So it is supplied by standard I/O and allows you to traverse a directory. So a dir, like a capital FILE, is an open pointer that allows me to do operations on a directory file. The operations are pretty straightforward. You may read an entry from it, and read dir is past the dir pointer and returns one entry's worth of information from the directory. So another way to look at the dir pointer is that it's an iterator that will walk through the directory with read dir to advance it and return each successive value. There is, by the way, a final close dir expected to shut down the iteration, just as one would do an fclose, for instance, on a capital FILE pointer. So what does read dir return? Well, yet another structure. This is the struct dir entry that I type-defed into something more civilized looking here. So struct dirent is the one I actually provided. Dir entry is the type-def I did. Oh, and since we're up here, we should point out that the include files to do this are actually in dirent.h, which you !include. And the others up here worth talking about briefly. The password.h is the one that gave me the information, the prototypes and return types for the user and group ID stuff that we did earlier. Unsurprisingly, time.h is the one that gives me the ask time and the GM time and so forth. So various header files to include to use all these things. Now, the dir entry, or rather a pointer to one, is returned by read dir, and as long as that is not null, we have a valid entry. It returns null when we've exhausted the directory. The member or field d_name is the one we'll use here of the dir entry, and it indicates the name of that entry, whatever file it is. And so we'll give that file name to lstat and get some stats on one of the entries in our directory. And then down here, we will do a write stats on the directory name and the file stats we just obtained, but only under the right circumstances. That if statement there. And that's an in-lecture question. What the heck am I doing with that if statement? If you read it out carefully, you'll see that we're checking the first letter of the D name to see if it's a dot. And we're using the all flag in ops, which was the one for -a. So what we're saying is, if we're either doing every single entry, dot or non-dot, or if the beginning of this one is not a dot, then we'll list it. By implication, if it is a dot file and we don't have ops_all, then we won't list it, and the loop will do nothing at all, in fact. So let's see here. If we do have the listing done, we do write stats, and then we come to here. What's going on there? Well, the file we just listed in the directory that we're dumping might, in its own right, be a subdirectory. We're testing to see if that is so. And if we are also asking to do recursion, listing the subdirectory's content, in other words, we'll make another call of list recursively. Indent will have 3 more values on it so that we get an extra indent level. We'll pass the directory to be traversed. This is the subdirectory, of course, and the options. And that subcall will come looping around and realize that we were given a directory and go back through this very loop for the subdirectory, printing all of its content. And of course, if that one has subdirectories, they'll get printed too, which is expected from the -R option. But there is one important thing we're doing here that we skipped over, lines 72 and 81. And again, a new Unix concept. Every program runs in a current directory, whatever directory you started it in, typically, and everything it does is within the context of that current working directory. Now, we opened up a directory here, like sample, for instance, and we're getting names from it, like file1 or file2, which are contents of sample. But if I just give that name to lstat right here, pass it file1, it'll come back with an error because in the current working directory there is no file1. So, for instance, I don't have a file1 here. If I do an ls of sample, yeah, there's a file1 in sample, but that's in sample. That's not in the directory I did my ls in, which is above sample. So I can't just pass file1 to lstat and have it make sense. I could prepend the name of the prior directory and make a /path name to pass to lstat. It'll accept that. But the cleaner way to do it is this. I change my working directory to sample, if that's the one we're traversing, and then the term file1 makes perfect sense within the context of that directory. This is sort of the in-program equivalent of a cd command in the shell. But it's changing your program's working directory, not the working directory of the shell that started it. Of course, I have to undo that when I come back from traversing, so I change dir to ... and that brings me back up one. So this recursive pattern not only traverses directories, it's also descending down into the directories and backing back up out of them as it goes. And that's about it then for our AltLs example. In a lecture segment coming up, we'll look at the data structures under the hood in the Unix kernel that help us keep track of things like file metadata and directories and so forth.